Okay, you have it fine?
Yes, it looks perfect. Thanks.
Okay. So again, hello from Split. It's quite sunny, as you can see from my window. This is a table of contents. I'm not going to go in much more details, and I have tried just to put a lot of text on the slides, so whoever is going to read later on through the presentation is going to have some details on how the whole work has been done. So for those who are not acquainted with the Ceratothoa, on the left picture, you have a Ceratothoa oestroides, which is a crustacean, an isopod, and it lives in the. Do you hear me? Are there any problems or?
No, we can hear you. I think there might be someone else just needs to mute there.
Okay. So Ceratothoa is in the mouth cavity, in buccal cavity of mostly sea bass, and sometimes also in the sea bream. While on the right side, you have a nice picture of Sparicotyle, which is a monogenia. So totally two different species of parasites. But they have same challenges in respect to the treatment and their infection in aquaculture, because there are no effective or environmental or consumer safe synthetic or natural compounds that are used nowadays to treat both of infections. And we need to highlight that there are some effective management measures, but they need to be in place all the time during the rearing cycles. There are some existing treatments for Ceratothoa. I think that it was also mentioned before in the session when we were talking about Argulus and sea lice. So some pyrethroid deltamethrin compounds, emamectin benzoate, which was feed administered and tested, and diflobenzuron. But for Sparicotyle, usually it's only formalin buds. So you know that formalin buds have now very limited use, and in Italy they have been banned at all, which is the rest of EU is going to follow. In general, bud treatments are unpractical, labor intensive, or quite unmanageable under certain circumstances. So if you have a high water temperature, if you have bad currents on your aquaculture site, it's not going to work. Plus, there is no long-lasting protection. So you need to repeat it over a couple of seasons. Another issue is that there are no registered parasiticides, or if there are some, they are rare, and usually you need to have importation license if you have a big outbreak, which you need to report at least when Croatia is concerned. So what we have been doing with different compounds, we have been testing LC50s. So for those that are not familiar with LC50s, it's a concentration of any chemical that kills 50% of the test animals. So it can be Ceratothoa, it can be Sparicotyle, and we also tested the viability of sea bream cells to see whether these compounds have any toxic effect on the host. So the experimental setup was quite similar both in Ceratothoa and Sparicotyle, and I have marked here the synthetic and natural compounds that we have tested. So we started with the same list, but quite soon we have realized through the experiment that some have no effect at all in monogenian, while they were quite efficient in Ceratothoa, and vice versa. I'm not going to read through all these experimental details, but also bear in mind that the sea bream fibroblast cells viability has been tested, and it has been tested for a range of concentration of all of these compounds from 0.1 up to 10 micromoles, which is quite high concentration. And in this slide, actually, you are seeing the graphs and the basic results of the synthetic and the natural compounds. So you see a vertical line which is crossing the graph. That one is showing you the LC50 of each compound. I didn't put the names of the compounds, so you actually see the results without the names, because we are still in process of deciding whether it's going to be published or we are going to test it further, some of them. However, please note in Ceratothoa that both the synthetic and natural compounds had similar decimal range of lethal concentrations. For Sparicotyle, there has been a quite dramatic difference between natural and synthetic compounds. We are still thinking what could be the reason for this, but in Sparicotyle, in contrast to Ceratothoa, synthetic have worked much better. So the last slide with lots of graphs is this one that actually showed you that it's showing you that no compound was toxic until 72 hours and at the maximum concentration of 10 micromoles for the fibroblast cells. We use Sebrim fibroblast cell line SAF1, and we think this is quite good, although I mean it's not really reflecting the status of the whole organism. So next steps for us would be to test the most promising of both natural and synthetic compounds in the field. We have a possibility to do this through another national project. It's Adria Aquanet Interact project, but we'll see how that one proceeds. We need also to go further with the pharmacokinetic study to see really the availability and metabolites in the host tissue to be sure that it's both consumer and environmental safe, and to see the economic moment. So how much of the specific compounds it's needed to have an efficient treatment in 1 ton of fish farm production. And for sure, we are looking for interested stakeholders to push this further, whether it would be just a farm willing to give us access to their fish or just experimental tanks. We still need to decide. So take-home message is that all of tested compounds are safe for the fish, so this is quite good news. For Ceratothoa, both synthetic and natural compounds had a similar LC50. Maybe is because of Hitinius carapax, we still don't know. And for Sparicotyle, we have found that synthetic compounds are working 2 times better than the natural one, which means that probably the natural one could be also incorporated in feed as additives, but again, we do not know much about Sparicotyle and Ceratothoa feeding strategies. So even though we have tested those parasites in vivo and in vitro, we are still not sure whether they are feeding by blood sucking or taking the tissue fragments. And such LC50 assays are quite time consuming, but they are the only ones standardized and validated. And no matter what compounds at the end we end up with, they need to be applied along standard management measures, so good, so excellent prophylaxis, and not to take out of mind that each farming site is quite different one from the other. So thank you very much for listening to me. It's a bit late, and I'm going to be here for more questions if you're going to have them. Thank you.
Great. Thank you very much, Ivona.